Did you actually save any energy? I'm here today wearing what definitely looks like a piece of notebook paper to talk about the math of energy savings. Imagine you made some gigantic change to your building that should reduce the amount of energy you use. All you need to do is look at how much money did you spend on energy the year before, how much money you spent the year afterwards, and that should be how much energy you saved, right? Wrong. There are a couple of key things you need to factor into your calculations. The first and most obvious is you can't use price or dollars to compare the year before to the year after the change. The reason is that price fluctuates. If the price of energy went up 20%, it's going to look like you used a lot more energy in the year afterwards. So if it's, for example, therms, you need to compare the therms in the year before to the therms in the year afterwards. The second piece is weather changes how much energy you're going to use for heating and cooling. So how do we deal with this? Well, there's an industry standard way of adjusting for weather, and it's called degree days. With heating, it's the number of degrees below 55 in any given day. Let's imagine your building used 100 therms in the year before you did the project and 100 therms in the year after you did the project. On the surface, it would look like you didn't save any energy from this energy efficiency improvement. The problem is we didn't factor in the weather. Now let's imagine that in the year before, the average temperature was 50 degrees, and in the year after, the average temperature was 45 degrees. Now I know what you're thinking, Lee, 5 degrees? How is that going to make any difference in how much heating I use? 55 minus 50 is 5 degree days. 55 minus 45 is 10 degree days. If you divide your 100 therms by 5 degree days, you get 20. And if you divide your 100 therms in the year after by 10 degree days, you get 10. So that project that looked like it totally failed because you used the same amount of therms, when you actually adjust for degree days, shows a 50% reduction in energy used. There are all kinds of other refinements you can do to make these calculations even more precise. But fortunately for you, math class is over. The key takeaway here is if you're actually trying to figure out if you saved money and energy from an improvement to your building, you need to make sure you're doing it in the unit of energy, not dollars, and you need to factor in weather. Better yet, if you have a great contractor, they should really be doing this for you. And now that you have a basis for understanding generally how the calculation should work, you can call bullshit if they're not doing it in a transparent and accurate way.